Alright, so today I'll be calculating the DTFT of the function we have right there, x of k equals k times 3 raised to the negative absolute value of k. So I have written the definition of the DTFT, which is x omega equals the summation of infinity to negative infinity of our function x of k times e to the negative j omega k. So with this, in our x of k, I know the geometric series that we want to work in order to solve our equation, which I've written it below. So our whole goal is to get our definition to match that geometric series. So the first thing that we're going to have to deal with is the absolute value that is being raised to the 3 that is being raised to the absolute value of k. So right here I'm just going to write what will help us out. So with this absolute value, you have numbers that are negative and numbers that are positive. So you can put a negative number in there and you can put a positive number in there. You're always going to get a positive number, but you can put a negative number in there. So for any negative number, so negative k, it's going to be like negative infinity. So basically you have a range of just negative infinity to 0 for all negative values of k, which is important because that will be our intervals for our series, and the reason why we have to also break our series into two parts, because now we have two k's or two parts to the absolute value, which is the negative numbers and the positive numbers. That's the main reason why we are writing two series. So with the first series that we're going to write, we're going to have 0 equals k to the negative infinity times k times 3 raised to the negative k times e raised to the negative j omega k. And then we're going to write our second series, which will be added to the first one, which will be infinity k equals 0. And then we're just going to write our x of k, which will be positive, though, the 3 raised to a positive k. So we have that now written out. Now, be very careful, because I know I overlooked it when I first did the problem, where our first series, where it has the 0 above our series, isn't in the same form as our geometric series that we're trying to solve for. So we have to find a way to change our series to match the geometric series, which in order to do that, we have to flip all the signs to our k's. So like we have to invert our k's. So now all the positive k's become negative k's, which is what I've done here. And so doing that, we just write out what we have, and then we're just going to solve from there, because from there I'm just going to write it in an easier form for us to really make sure that it matches our geometric series. So for our series, it has to be some value times r raised to our k, which I am going ahead, I'm putting it in that form right now, and then we're just going to use our geometric series to write our solution, and that'll be it. So now that I've written out, I've simplified my series to match the geometric series, so now we can go ahead and use the geometric series that I've written to come at our answer. So when using the geometric series, it'll give us the DTFT that we're looking for. And this is what we want from the start. Alright, so I hope this video has helped you learn any tricks that may come at you while solving DTFT problems. Thank you, and until next time.